How do we add and subtract radicals? The rule is, we can only combine like radicals. Like radicals are radicals with the same index and the same radicand. For example, square root of 3 and negative 4 square root of 3. So they have the same index, the same radicand. Similar with this given example. What are unlike radicals? Of course, these are not like radicals. So they may have the same radicand but they have different index. Shown by this example. Cube root of 2 and square root of 2. They have the same radicand but they have different index. How about this one? Fifth root of 6 and 3 fifth root of 7. They have the same index but they have different radicands. Okay, example number 1. We have here square root of x plus 3 square root of x minus 5 square root of x. So we just add the numerical coefficients of the radicals and then attach the common radical. So this is, the coefficient of this is 1 and this is 3 and the coefficient of this is negative 5. So 1 plus 3 minus 5. That is negative 1. So negative 1 square root of x. Another way of simplifying is we factor out the common radical. So we factor out square root of x. So if you factor out square root of x, numerical coefficient will remain square root of x times 1 plus 3 minus 5. And we simplify this. 1 plus 3 minus 5. The answer is negative 1. So negative 1 times square root of x, or simply negative square root of x. Number 2. 5 square root of 2 plus 10 square root of 2. So we just add the numerical coefficients and attach the radical. So we have here 15 square root of 2. Number 3. Square root of 11 plus 3 square root of 13. In this case, we can no longer simplify this. So the answer is as is. This is a simplified form. You can no longer add the 2 because they are unlike radicals. The question is, if you have unlike radicals, can you not simplify them further? Let's look at number 4. Square root of 50 plus 3 square root of 200. At first glance, you see that they are unlike radicals. But these radicals are not written in their simplest form. So before we conclude that this can no longer be simplified, we first write them in their simplest form. So square root of 50 written as 25 times 2. And then square root of 200 can be written as 100 times 2. Okay, we can extract square root of 25. 5 square root of 2 plus 3 times square root of 100 is 10. So what remains is square root of 2. So 5 square root of 2 plus 3 times 10, 30 square root of 2. So this radical here, the given radical, can be written in this form. So you see, we have like radicals. We can now add them. So the result will be 35 square root of 2. For simplifying these kinds of radicals, I discussed this in my first video. How about the second example? 6 cube root of 16 plus 11 cube root of 2. 3 cube root of 2, this is already in simplified form. For 3 cube root of 6, we simplify it. 6 cube root of 16. So we need to find factors of 16 that is a perfect cube, and that is 8. So 16 can be written as 8 times 2, and then we write 11 cube root of 2. 6 cube root of 8 is 2, so we multiply it to the numerical coefficient 6, and then we write cube root of 2. So plus 11 cube root of 2. we now have like radicals. So 6 times 2, 12, cube root of 2, 11, cube root of 2. We now add the numerical coefficients. 12 plus 11, this is 23. 23 cube root of 2. That's for example number 5. Let us have example number 6. You notice that they are not like radicals because they have the same index but they have different radicands. So we try to simplify them. You know that 81 is a perfect square. 81 is 9 squared. It is also equal to 3 raised to 4, but it's not a perfect cube. 625 is 25 squared. It's also 5 raised to 4. So we try to simplify. Negative 3 cube root of 81. We write 81 as a power of 3. 3 times 3, 4 times. Plus 5 cube root of 625. 625, we write it as a power of 5. 5 times 5 times 5 times 5. So from this factorization, we can rewrite this as 3 cube times 3 plus 5 cube root of 5 cube times 5. So we were now able to write 81 as a factor of a perfect cube and the number 3, and similarly 625 is written as a factor of this perfect cube and 5. We now extract these roots. So negative 3, we extract the cube root of this, that is 3. So we are left with cube root of 3 plus 5. We extract this cube root, that is 5, and then we are left with cube root of 5. So negative 9 cube root of 3 plus 25 cube root of 5. But unfortunately, as you can see here, upon simplifying, we still have unlike radicals, so we can no longer simplify this further. So this is now our final answer.